Thank you all for joining us today and welcome to Career Explore Northwest Live. My name is Tina Swanek and I'm the Career Explore Northwest producer for KSPS PBS Public Television here in Spokane, Washington. And thank you again for joining us today for this event. Career Explore Northwest Live is an interactive Zoom event that connects young people with professionals to learn about careers and career paths. And today we're going to be learning actually about two careers. We're going to be learning about controls engineer and controls technician with the help of our special guests up on the screen, Tanner Short and Dan Brockman of Pearson Packaging Systems in Spokane, Washington. Tanner on the left is a junior controls engineer and Dan on the right is a controls technician. A little bit of background about Pearson Packaging Systems. Pearson Packaging specializes in secondary packaging automation solutions such as case erectors, robotic top loaders, sealers, and robotic palletizers. Secondary packaging refers to boxes that hold multiple individual products and enable the safe transport to a retailer or a distributor. With 70 years of experience, Pearson has deployed more than 23,000 machines worldwide, helping high-volume manufacturers, co-packers, and distributors to grow their operation by overcoming labor cost, supply, safety, quality, and throughput challenges. And the company's expertise actually extends beyond machine design and build. It also includes system design and integration, project management, and after-sale support through machine upgrades, modifications, and technical services. So hello to Tanner and Dan. Thank you again for joining us today. We appreciate you taking your time to share your information and background and some tips, hopefully, with our student guests. Now let's meet our guest high schools. Joining our event today are students from North Central High School with engineering instructor Ryan West. Hello, thank you. And students from Ferris High School with engineering instructor Gary Gillespie. Again, thanks to the instructors and all of our student guests for participating in today's event. And just real quickly, before we get started, I wanted to quickly share the agenda for the event. First, both Tanner and Dan will give us a quick overview of their educational and career journeys. And then we're going to open the floor for questions from our student guests from North Central and Ferris. And we won't be taking any questions through the chat today. We're instead going to be engaging in this live discussion. Okay, so let's get started. Again, welcome, Tanner. Will you please tell us a little bit about your work as a junior controls engineer and your career journey?
Absolutely. So I'm Tanner Short. I'm a junior controls engineer, and that means that I'm responsible for programming all of our equipment. All of our controls engineers are able to take all the hardware, like these machines you see behind me, and make them do what they're supposed to do. So we program the robots, we program all of the moving vacuum components, any automated equipment, and then we make sure that it performs the way that our customers expect them to behave. We have the opportunity to do that with live hardware, with real live machines. We also have the opportunity to do that with virtual machines that are still in the design phase. So machine models that are designed by our mechanical engineers via 3D CAD modeling software, we are able to take that and start programming it in the computer. And that way we can do tests and other programming concepts before we move it to the real machine. A little bit about my career path. So I studied as a mechanical engineering student at the University of Utah. I did a 4-year bachelor's and then a 1-year master's program specializing in robotics. I was fortunate to have 2 internships before coming to Pearson Packaging Systems as a mechanical design engineer. But then I joined Pearson Packaging as a controls engineering intern, so transitioning from designing machines to actually programming them and making them function, which to me is really exciting. I like being able to take machines and actually make them do what they're supposed to do. I mean, it's cool to design robots, but I like making the robots move. And so like this machine behind me, a robotic case erector, is able to take these boxes out of those magazines, build them, and then put things into them. And so to me, that's really exciting.
Thank you so much, Tanner. We appreciate a little bit of background from you. And then we're going to move over to Dan. Again, welcome, Dan. Will you also please tell us a little bit about your duties as a control technician and your career and educational journey?
So part of what I do is controls work or controls technician. So the control side of things is basically we're taking the programs that Tanner and his coworkers create for us, and we're actually programming the machines that are out on the assembly floor, which is where I work. But I also do the mechanical and electrical side of things as well. So when we're building machines from scratch, we're actually using 3D models like what you see back here to help build a machine. And we can hide different parts and components from this 3D model to allow us to build it. And then also doing the electrical work, which includes running cables, running pneumatic plumbing lines. And then we wrap it up with the controls work, which is actually programming the machine itself. So for my educational background, I graduated from Reardon High School, and that was as far as my schooling education went. But like a lot of people, I grew up, working on cars with my dad. I did a little science Olympiad in high school, but that's about it. A lot of my training's become on the job. So started as a mechanical technician, just building the equipment, and then I wanted to learn more, so I bugged one of our electricians to teach me how to run cables and wire up our enclosures. And once I got past that, I decided I want to do controls work. Being that I'm also a field service technician, I got to go out and install machines. I had some of the software on my computer that allowed me to do that. And so I just kind of took that and ran with it and decided I can do this on my own, and kind of did the whole encompassing process here on the floor, which is mechanical, electrical, and finally controls work, which is programming the machine.
Thank you so much, Dan. And now we like to have the majority of the event be student questions. So we'll go ahead and start the question and answer portion of this event. And as a reminder, we won't be taking questions through the chat today. And we're going to start with a question from North Central High School, followed by Ferris, and we'll continue in that order throughout the event. And students, before asking your question, if you could please state if your question is for Tanner or Dan, that would be very helpful. So North Central High School, what is your first question?
My first question is, what type of struggles did you guys have when you first started out, and how did you overcome them?
I can go first. So the struggles that I experienced when I first joined was transitioning from the theoretical things I learned in school, so a lot of math and science, to learning how to actually program machines here on the floor. So the things they teach you in school can be pretty generic, pretty broad. They want to make sure that you understand a lot, so you have options on where to go out of school. They didn't really teach me the specifics that I'm doing here at Pearson. So there's a pretty large learning curve of how to use all the software that we use to program, learning how to do a lot of electrical design, because being a mechanical engineering student, I didn't have a background with that. So there's just a big learning curve. And then learning how we solve our customers' problems, because there's always a million ways to solve an engineering problem. And so learning the best practices, the ways that Pearson Packaging Systems has solved its customers' problems, and being able to learn from a lot of the senior engineers. That took some time. It really did.
So for me, similar to kind of what Tanner was saying, I mean, my biggest struggle, I would say, is kind of the troubleshooting side of things, not just for all aspects as far as mechanical, electrical, and controls. I mean, they each have their own different troubleshooting and problem solving components. So with mechanical, it'd be how to make parts fit, make parts work. Electrical could be kind of diagnosing an issue we have with our electrical circuit or power systems. And then the final side is controls, which is sometimes the program doesn't exactly work the way you want it to. So it's diving into that and figuring out what bits are toggling on and off and things like that. But I mean, this comes with time. I mean, the more experience you have with what you're working on, the more familiar you can get with it. And then you can use whatever troubleshooting or problem solving skills you learned on one thing, you can always apply that to something else.
Ferris High School, what is your first question for Dan or Tanner? And again, if you could please specify which of our guests your question is for, that would be helpful.
So my question is more for Dan. So I actually got to go tour Pearson Packaging over the summer, and a lot of the robots that I got to see and all the different machines that were working were near the end of the process. And so there wasn't a lot of us getting to see the beginning stages. And so I was just wondering, what are the biggest challenges that and the processes that you guys come together to get over? So if there was a choke point, how do you guys figure out a way to get past that? And I guess, what's the process of getting it from that computer into real life? Like, I guess the person on the floor, how do they just put it all together?
So, I mean, we start from scratch with every machine. So what we do is we get a blank frame, and we don't really have one I could show you guys right now, but a blank frame with no parts on it. And we get multiple parts carts that are just full of individual pieces of fabricated parts that Pearson designed. and also what we call OEM or purchase parts, which is things like bearings and sprockets and things like that. But we're then basically starting from, a good rule of thumb is you start from the inside, work your way out. So this machine that I'm standing in front of right now, start with a blank frame where all you see is the tubing, and we work our way from the inside out, just putting components on, using this 3D modeling. And the nice thing about our 3D modeling is that we can hide parts, hide layers, hide sub-assemblies. Now, if I can kind of give you a quick example here. So right now you're seeing a model with all the guarding on it. But what you can do is you can see an entire list of part numbers here. And then if we want to, we can hide entire assemblies from these 3D models. Hello, and that's how we can look at machines. And we can actually take everything down to the individual components that make up the machine and build from there. So, I mean, a choke point can sometimes be our supply chain as far as getting parts in. We have a high demand. And it's just basically we're working around those problem areas, but we can't work on something, so we'll work on something else kind of thing. It's a large question as far as different choke points we can reach. But we do our best to work with the engineers, supply chain, and our supervisors and managers to identify how we can keep the project moving forward.
North Central, next question.
Hi, this is for both guys. What surprised you most about your job?
I think what surprised me the most was how cool the robots were in real life. Because, we see a lot of robots in our day and age, and these are admittedly fairly simple robots. We call them pick and place. They just will pick something up and they'll put it somewhere else. But making them move and do what you want and then automatically do it themselves once you programmed it, it was pretty surprising to see how efficiently and how precisely they can do their job. And it was almost shocking to think that I was able to program it to do that. And then another thing that surprised me here about Pearson Packaging is our ability to program and design things virtually prior to startup. Being able to actually make the machine move and function the way it will in real life, virtually, like in a 3D model environment, and then move that program to the real machine and see it do almost exactly the same thing in real life. I think that's a pretty surprising, powerful thing that we're able to do here.
And for me, one of the surprising things that I found, because I'm able to go on the road and be a service technician to install machines, and it's just knowing the diversity of our customer base and where our machines have gone. So we have a lot of equipment that's in the US, a lot on the East Coast, but we have machines that we've installed in Australia, Scotland, Thailand. We've been all over the world with Pearson, and just the immense diversity of our clientele and our customer base. But also it was very quickly, I realized that Pearson Packaging, because of the people that I get to work with, like how quickly I decided that this is a place I want to have a career at. Like I'm not going to retire until they kick me out of the door.
Great. Next question, Ferris High School.
My question is for both of them. What new skills have you developed as a professional since taking this role?
One of the biggest ones for me has been communication. Again, when you're in school and you're deep in the math and the science and the theoretical knowledge, there's not a lot of training on how to communicate with other engineers, communicate with customers. So learning how to communicate through problems, troubleshoot as a team, that's something I feel like I have learned since being here at Pearson. And then there's just some really powerful troubleshooting skills that I've gained here. Like Dan is saying, a lot of these controls technicians, engineers, they've been doing what they've been doing for a long time. And so there's been a lot of skills they've been able to pass on to me as a junior controls engineer on ways to work through issues that come up, things that don't go as expected, how to break down a big problem into lots of little problems and kind of go after those little problems one by one in a, very collaborative and fairly risk-free way. I think those probably been the two skills that I've been able to learn since joining Pearson.
My answer is going to be very similar to Tanner, is as far as this developing solid troubleshooting skills, especially being out on the road where you're not at home, you're not in our warehouse where you're able to rely, you can go grab, the senior guy for whatever department that is and get his assistance on it. When you're out on the road in front of a customer, it's all on you, and you got to troubleshoot and figure things out. And that's not just, it's mechanical, it's electrical, it's control, it's all of that. So we do have a resource back here at Pearson that we can reach out to, but for the most part, you develop pretty solid troubleshooting skills. And also some leadership skills as well, as far as managing projects, managing your time. That's an important thing because that's one thing that we're judged on is how quickly we can do things and if it's on time.
Next question, North Central.
My question is for Tanner. Who was it your like idol for your job? Because Dan said it was his dad, but who was yours?
Good question. So, I mean, as a child, I did look up to my dad who's in construction. So that hands-on work made me kind of want to gravitate towards the hands-on stuff. But I had a teacher when I was in elementary school, and she started up a robotics program, the first Lego League program at my elementary school. And so she was really influential for me, looking at engineering specifically and robotics, because that was something I had never even thought of before. And she invited me to join the team, and I loved Legos, still love Legos, and so Lego Robotics League was appealing at the time, of course, but then learning to go through and design robotics systems, even at that level, became something really, really exciting, and I think that really started my career and education journey in robotics. So I'd say she really put me on that path.
Ferris, next question.
My question was for both of them. What do you think is the best way to earn a job in this industry?
I mean, you certainly can go the route I did, a 4-year engineering degree to either. So we have 3 types of engineers at Pearson. We have a controls engineer like myself that does the programming. We have a mechanical engineer that designs the systems. And then we have applications engineers that take concepts that potential customers want us to build for them and then make preliminary designs and some evaluations. So a 4-year engineering degree is a good way to go towards that. There's also a few engineers here that have 2-year technical degrees, and they're able to go straight into like what Dan has talked about, field service, or even some controls engineering here on our shop floor. So that's one route that I could speak to.
Tanner, do you know what those
So-
technical degrees are?
Some of them are like electrical technician degrees, or even just 2-year electrical and mechanical design degrees. So specific to what our engineers here do. Those are a couple that I know of. I guess I should speak to the 4-year degrees too. There's mechanical engineers like me, there's electrical engineers, and then there's computer science as well. We have some from all 3 of those disciplines.
And I mean, as far as what I did, obviously, like I said, I didn't go to any school after high school. And for me, starting here, I had an opening, and it was a mechanical position, so mechanical assembly technician. And I knew I did stuff like that growing up as far as being mechanically inclined, and so I just applied and started. But I mean, the biggest thing is if you got the drive and the desire to complete the tasks that you're given and things like that, that's kind of your biggest thing. Is are you willing to work hard and put in some long hours to get things accomplished?
My question is for the both of them. Like, what kind of decisions do you have to make in your role, like as a leader?
Yeah, that's a great question, because there are a lot of decisions that the both of us probably have to make. For me, I mean, we can be making decisions at the beginning because we're involved in the design process when we're looking at what machines we think or what components we think will solve the problem. So we have to make decisions about, well, what kind of robot might we use? How might we control the other systems as far as like taping up cases or putting products into boxes? We also might have to make decisions about how do we tackle very specific requirements from the customer about ways that boxes need to face, how we might put labels on boxes, or a lot of other decisions up front. Then when we're on the floor and we have the machines that we're programming, there's other decisions about how do we solve the problem? Because again, there's a million ways to solve a problem, and we have to make decisions about how are we going to go about tackling this, especially when problems come up like Dan talked about, where really you're the only one that everyone's looking at to make sure that the machine, it does what we promised it will do. So there's those technical decisions we have to make. There's also a lot of decisions that have to be made as a team. So I talked about communication. Sometimes we have to talk to the customer and say, hey, we've encountered something. something we didn't expect. Let's talk about and decide how we want to move forward. Like, if we need to modify the machine design to make it appropriate for this problem, or if we can make it work as it is. So there's a lot of decisions around problems that come up, or even just how we design our machines from the engineering standpoint.
And again, similar to what Tanner said, we run into a lot of decision-making points of the day, especially when we're building a larger system on the floor. So we're kind of taking all that designing and application that engineering has done, and then turning that into an actual real thing here on the assembly floor. And especially with our robotic systems and entire lines that we're building for customers, we got to decide throughout multiple times a day is who do we need to have working on this? Because we do have people that are more specialized in some things than others, or who have more time working on things as far as, let's say, electrical, or more time building. So we're making those decisions to put people where they need to be in order to make the project perform as best as possible. So that's some of the biggest things that we do and deal with. And then again, like what Tanner said, when you're out on the road by yourself, you're making all the decisions. You're kind of your own boss in a way out there. And I personally find a lot of enjoyment in that, because then it's on you, and that way when it works good, it's again all on you. So either they're looking at you good or looking at you bad, but you're still trying hard out there.
And if I could piggyback to another thing we have to make decisions on, sometimes we'll have multiple machines going at the same time. So we'll have, like, I could have this robot here, but there may be another machine across the way that I'm also responsible for programming, or Dan's responsible for building and programming. And there could be times where those machines are both high priority at the same time. So then there can be a lot of decision making about, how do I spend my time? What time do I dedicate to this project versus this project over here, when they're both important? They both need time. So there can even be some project management decisions that we have to make day to day.
Ferris High School, next question.
Hi, this could be a question for both of you, and it may be a little bit vague, but how much innovation do you do versus working on and maintaining existing projects?
Yeah, I think there's a little bit of both. I think there's plenty of things we do that are just kind of following standards, because standardization helps us reduce problems. But man, I work with innovation probably every day, because with robotic systems, they're very custom. We get a lot of different products that customers want us to provide for, and a lot of unique issues that come up with robotic systems, and just how they're designed, how they're laid out. And so there's been a lot of innovation that we've had to come up with. We have to constantly evaluate, okay, how do we take what we've done for years and make it a little bit better for this particular customer? And even some of the things that are standardized, we have to look at those and say, okay, how can we improve this? How can we make this a little more competitive, or even a little more efficient? So I feel like in what I do every day, there is quite a bit of innovation and trying to think creatively, for especially creative problem solving.
Yeah, and the vast majority of anything innovative, we stay pretty status quo on the floor, because the vast majority of the machines that we're building, we've built hundreds, sometimes thousands of those machines. And so we're kind of just doing a lot of repetition, but over time, we've seen, even the 8 years that I've been here, you'll see small things change on machines, like going from an AC motor to servo controlled machines, different pneumatic assemblies and different parts like that. Where Pearson is innovating and trying to stay with the curve with what the market is doing right now, or with the standard in the kind of packaging industry is. But I was also fortunate enough to work on a project just a couple of weeks ago, which was a brand new machine design that Pearson did, where I was able to help actually check the machine out, troubleshoot it, and it was one of one for us. And so it was actually pretty cool to be able to be on a prototype machine that no one else has touched or seen, and that we can actually bring to market and sell to customers.
What was your guys' newest program or creation?
So yeah, it was the newest prototype machine we just finished doing. We call that our new CE15. So CE stands for case erector, and Pearson's pretty consistent with what we call machines. So CE is case erector, CS is case sealer. But that prototype machine was pretty interesting, because it was basically, we're taking a design, and this is a big push from upper management to make a machine that not only functioned well, and that's obviously the main goal, is for a machine to function well consistently for our customers, is also kind of bring it into the modern age of what a machine should look like as well. So that machine had a lot of innovative stuff on it as well, as far as servos, pneumatics, and things like that. And it was cool to be able to be part of that, get things running, get it running good, and then that carry on to down the road where we're selling, I don't know, however many we do, but it's cool to be part of that groundbreaking process of a brand new machine and a prototype.
Hey, Ferris High School.
My question is for Tanner. What is the most frequent challenge you face while working with the robots?
I think the thing that I see the most frequently is the robot being able to get where it needs to go, because these robots, I mean, they will literally go where we tell them. So if I didn't think through where it needs to go, then it can do something unexpected. Because when you program a robot, you'll program its path, its motion, and then once that is good and solidified, then it will just do that again and again and again. But a lot goes into making sure that those are right, especially because, you know, customers, they need the robots to have a certain output at a certain speed. Like we need to see this many products per minute. And so you can get into the nuances of how robots move from point A to point B to make sure it's done in a quick enough pace, but also doesn't burn out your servo motors in 5 years, because these need to run for a long time. So I think what I see the most consistently on these robot projects is getting down to the nuances of how the robot's going to go from point A to point B while satisfying very competitive customer requirements.
North Central.
What is one of the most interesting or most rewarding things you've done in your job?
I think for me, I'm really interested in the emulations we do, where we take the 3D CAD models on the computer and we program them in advance. Because one common choke point for engineering is we'll design a machine and then we release it, which is basically saying go, and our supply chain team will go purchase everything, all the parts. I mean, thousands of parts for a machine. And so that obviously takes quite a bit of time. And then Dan's team will start assembling it, building it. You know, that takes a few months. And that's a few months where we as engineering kind of have to sit back and wait for it to be built before we can program it. Well, once you introduce emulations, you can start programming that machine as soon as you release it. So while they're buying parts and they're assembling it, you're able to program the full live machine, even though it's virtual, make it do what it needs to do. Like I was saying, you could program the robot motions and figure out how the program needs to function to get it from point A to point B, and figure all that stuff out before the machine's even built. So that as soon as they put power on it, put air on it, you just bring the program down, download it to the controller, and you're moving from day one. So I think that's something I enjoy the most, is being able to do the emulations, do the computer stuff.
I think for me, some of the biggest things I enjoy is I've been given and have the ability to kind of learn different things and do new things in my career field. Like I said, I started as a mechanical guy. I really wanted to learn the electrical side of things here, and I just pushed for that. And I was just kind of standing over the shoulder of one of our older electricians here and kind of poking at him to teach me. And that's how I learned electrical. And then same thing with controls, is you just kind of push your way into wanting to learn something. So if you show enough, drive to do it, the good things can kind of come out of that. I mean, and the other biggest thing I get to enjoy is everybody I work with. I mean, that's part of why I want to have a career here, is because I work with a great group of guys on the assembly floor. We have a great time when we're working. Kind of feels like you're going to hang out with all your friends for 8 to 10 hours a day. Because I learned from a lot of old guys. When I first started here, there was guys that were here for 30, 35, 40 years. And sometimes they're a little harsh on you. They don't mince words when it comes to telling you you're doing something wrong, but I appreciated that and I enjoyed working with them. So that's been some of the biggest enjoyment I've gotten out of working here.
Hey, Ferris High School.
Yeah, so this one will be for both of you. I guess I just want to ask, what different opportunities are there to grow inside of Pearson Packaging career-wise? And how do you think that compares to different companies with like different roles going up? And would you need like a higher education to step up that role inside of the company?
So engineering is fairly straightforward. So you start as a junior like me, and then you move up to a controls engineer. And controls engineer has a lot of same responsibilities. And then once you've been there long enough and you've learned what you need to learn, you can become a senior. So there's 3 levels of engineering. But from there, you could move into engineering management or even project management. So if you enjoy the leadership aspects and you enjoy managing and helping keep things on track and on budget, you can move in that direction. Usually usually Pearson values some business education if you're going to move in that direction. It's not a requirement, but it helps. And so I think Pearson is unique because we are smaller. So I guess we're kind of a small, big company. It's how I like to think of it. And so there's opportunities to grow, which is unique from other maybe small companies. But then it's also not as difficult to move up that ladder as it might be in a really big company. Because like Dan said, if you're willing to learn, there's people here who can teach you. And then there are clear growth opportunities to kind of move up in your career.
Tanner's absolutely right about that. As far as if there's plenty of people here who are willing to share some knowledge and some experience. You might get a hard time for it every once in a while, depending on who you're talking to. But at the end, like there's plenty of growth that I've experienced here. I mean, I started just putting nuts and bolts together on machines to now I'm able to kind of do all that, the electrical and controls and the service work. And Pearson also, if they see that you have the drive to do something, they will also kind of push you in that direction as well. So something I was able to do is they allowed me to take a FANUC training class. So FANUC is our main supplier for our robots, kind of like what you see behind Tanner right now, where I get to work with the robot, work with what we call the handling tool, which allows you to move the robot around. I've been fortunate enough to go through a UL class to certify our electrical panels for the field. And then past that, it's all the way up to management of what's happening on the floor. So Pearson is line structured. So we have different lines on in our assembly floor. And for example, my direct boss, he started as a guy who was just a mechanic on the floor. And now he is the manager for an entire line on the floor. So there's lots of growth. It's just showing that ability and showing that drive that you can do those things is kind of the biggest factor, and that's what they're looking for. One person that is well-rounded in what they know and what they do, but also somebody who's a good leader as well.
I think we have time for one more question from each of our schools. So North Central.
What's the biggest project you've worked on in your career?
For me, it's the one I'm sitting on right now. This is for a customer who's actually asked us to build 5 machines, and they're a customer who is really data focused. So they have in their facilities, they have servers that will collect data on all these machines on how they're performing. And so it's been challenging because like we have to figure out how to track that data ourselves and actually deliver it to the customer on each of these machines. And then as we make improvements from machine to machine, we have to make sure that those improvements go back to the others that we've already installed in the field. And so this customer has been really interesting to work with, really exciting to work with, because there's a lot of innovation, a lot of stuff we've been able to do that we've never done before. But it's also been very challenging because there's a lot of requirements that go with that, a lot of expectations, a lot of communication and working together with them to figure out how do we solve this? How do we provide what you need us to provide? And so this is the last one, the last one we're building for them for this project. And so far we've learned a lot and things have gone pretty smoothly on this one as we've been building. I think we've learned a lot, but it's definitely been the biggest one that I've worked on, to have 5 robot machines for one customer.
And for me, the biggest project that I've worked on, and also the biggest equipment that we make as far as case directors goes, it was 12 machines, all exactly the same, and each machine is about 53 feet long. The big machine that makes big boxes, and that was definitely the biggest project. It's also one of the biggest challenges as far as now you're not just managing one machine, 2. Now you have 12 that you're now having to coordinate your manpower correctly. And things like that, we try to get into a little bit of almost like an assembly line structure where you have one person building all of this on one machine, they go to the next one, do the same thing. Same thing with electrical. Our electrician will run all their cabling and wire up all the motors and devices, wire the panel, move on to the next one. It just kind of keeps on rolling down like that. And that's where we get the troubleshooting side of things with parts not working quite right, but also working around any kind of supply chain issues that we may have, because that's a lot of parts for a lot of machines. So that was definitely the biggest project I was a part of.
Ferris High School, this will be our last question for this event.
My question is for both Tanner and Dan. What is the most stressful part of your job?
I think tight deadlines is when things start to get a little stressful for us, for me particularly. I mean, like I said, I could have multiple projects, sometimes 3 or 4 different machines that are all getting really close to a factory acceptance test, which is where we have the customer come to our factory and check out the machine. And it's kind of like a final exam. They'll come and look at all the work that you've done for the month, all the months prior, and they'll give you a pass or a fail. So when we start getting really close to that, especially when there's multiple machines that are getting close to that factory acceptance test date, then it's kind of crunch time. And so there might be long hours because problems will always crop up. No project goes perfectly. And so things will crop up even close to that deadline. And so the most stressful part is getting those problems solved with a little bit less time, a little more urgency, and keeping our projects on time as much as we can.
I think the more stressful situations that I kind of come across since I've been here, it's definitely being out on the road, where you're troubleshooting a machine that, you know, the day before the customer called, said the machine's down, and then all of a sudden you're on a plane that night or the next morning to fly out to wherever it might be. There is some stress involved in that, but I personally enjoy it. I like that challenge of, you know, flying out last minute to wherever in the country and figure something out for the customer. So that is definitely where you can get some high stress times, and somebody might be screaming down your neck for a little while, but then once things all start running again, they want to take you out for dinner. So I enjoy the good balance. The stress is kind of nice, figuring things out, and at the end of the day, you're just getting better because you're learning something new if you haven't seen something before. So
Okay, well, I think we've come to the end of our event today. And once again, I'd like to thank our special guests, Tanner Short and Dan Brockman, for taking time to visit with us today. And we really appreciate all of the information and the special insights that you shared about your careers with our guests, our student guests. And thanks once more also to Ryan West and the students from North Central High School, and Gary Gillespie and the students from Ferris High School for participating in today's event. You guys had amazing questions, really well thought out, well constructed questions. So thank you for taking the time to prepare for the event today. And that concludes this Career Explorer Northwest live event.